Right. There was one question whether you can predict if the data will be skewed before collecting. And the answer to that is no. Generally speaking, it's after you collect the data that you would want to do a test of normalcy to see whether it's normally, the data are normally distributed or not. Then you would know what test to use. But like Prof. Yosin said, most of the times, what we collect would end up being normally distributed. Now, there's one question: when would you use chi-square test instead of logistic regression? The chi-square test, the figure you would get, all it tells you is that there's an association. For instance, if you do a chi-square test between the example that Alfred gave, between clinic attendance and outcome of the baby, whether the baby is dead or alive, all you would get is that there is an association between clinic attendance and whether the baby's outcome. And you know whether that association is significant. When you do a logistic regression, it gives you the strength of the association. So that's what he mentioned, that there'll be an odds ratio. The logistic regression will then tell you that women who attend the clinic have 3 times the odds of having a live baby compared to women who do not attend the clinic. But the chi-square will just tell you there is an association. It won't give you the strength of the association. So when you want to state the strength of the association, then you go on and do a logistic regression. But it's always helpful to do the chi-square test first, so that you don't end up doing logistic regression on a bunch of things where there is no association. So that's to answer the question. Why would you use a chi-square test instead of logistic? Thank you, Prof. Alfred, you want to add something to that?
No, Prof, it's all right. Okay. Thank you very much.
So you can take the other questions now. The ones that I've answered, I've kind of like removed them by clicking done. Yeah.
How do you use confidence interval to determine statistical significance? When you are determining risk or things like that, and you want to find out whether this is significant or not, then we say that the confidence interval should not contain 1. For example, you can have 0.9, a negative 0.9 ranging to 0.35, because 1 sits there. But if you have it 0.2, which is positive, to another 0. Let's say 4, that indicates that it's significant. And in fact, we will say that the confidence interval supersedes even the p-value. Once you have the confidence interval that clearly indicates this, then there is an inherent association between what you have found. So that is what we use to do the interpretation. If the samples are not taken well, and then you see that the confidence or the interval is so huge, then there is a problem. It tells about then you cannot really depend on the confidence interval, the limit, the lower and the upper limit for your explanations. But generally, if it is in the direction, as I've indicated, then you can safely say that, yes, it is. When will you use F-test rather than independent t-test? The F-test I indicated is for 2 or more groups. Let's say you want to determine the mean hypertension, mean what? Blood pressure, sorry. Mean blood pressure among adults 40 to 50 years in urban, rural, peri-urban areas. In that case, you cannot do the t-test because t-test will not be able to deal with those three categories. You deal with those three categories, and then it indicates whether the difference is between urban and rural. Or first, what analysis of variance will do is that, in fact, there is a difference. That's the first stage. And then you go further to do analysis to indicate whether the difference is between urban, rural, rural, urban, or urban, peri-urban. Where is the difference most significant? Things like that. That is what the F-test can do for you. So even if it's 4 categories, it can do first. Difference between and difference within. It does that. That really there is significance. But where is the significance most important? Is it between A, B, B, C, C, things like that, those pairings? Should the test about data precede or come after the table or figure? It depends. But generally, I don't know the style the colleague prefers, but it is always better sometimes to bring the test, then you include the table. Sometimes even in published papers, they take out the tables. So the test is key. So it's better a little description of what is in the table, then you bring the table as indicated in figure or table something. What you need to avoid is in your test or something, you try to avoid above or below, table above, table below. Indicate the table number, figure 2, figure 3. So if at the end of the day you are formatting your work, you are trying to finalize it, and then you said below, but it goes above, it creates problems. But if you say figure 4 will always be figure 4. It doesn't matter where it is in the text. So I think, can you explain inferential statistics? We explain descriptive. All right. Inferential statistics is when you want to use information that you have gathered to project, forecast, or predict something about the target population, as I indicated. So you take your sample. You couldn't have taken the whole population, but you are taking a sample so that at the end of the day, you can talk about the whole population. That is what inferential statistics is. So you use the statistics that you have derived from your sample to be able to estimate the population parameters and talk about the population. Then you can forecast that, okay, a woman who does not attend clinic have 3 times the risk of losing the baby compared to those who are. Those are all inferential things you do.
Alfred, could I make a comment there? Just to clarify. I mean, what Alfred presented, actually, most of it was inferential statistics.
Yes.
The chi-square, the t-test, all those things are inferential statistics. The descriptive one is just the early part you talked about, where is the tables, the graphs, and the charts. But the majority of what he presented was inferential statistics. And that's what we want our residents to be doing, not just reporting something that is purely descriptive. That is very basic statistics. I think even Alfred doesn't ask his medical students and community to do a little more than that. Yeah. Okay.
Thank you, Prof. So somebody says, I'm not sure of the difference between regression analysis and logistic analysis. Okay, let me make it simple. Usually for the linear regression, whether linear, multiple, the outcome variable, you know, they are all like the equation of the straight line. Y is equal to mx plus c. The y, which is the outcome that you are interested in for a linear regression, usually is a continuous variable. For that, for regression, logistic regression is categorical. So you want to explain the difference or the odds among this categorical outcome that you are interested in. The linear regression deals continuous measures. So you can also apply the correlation coefficient and other measures to it. But for categorical measures, you cannot do that. So I believe that is it. But then the interpretation is what Prof highlighted to indicate the odds of being a yes or being a no. Somebody is also asking, assuming there are two variables that one wants to find association between. If one of them is normally distributed and one is not normally distributed, which test parameter or non-parametric is appropriate to determine? So this one, you take it at a general level. You look at your data and then you do a test of to see whether the data is normally distributed or not. And once you determine that the data set is normally distributed, you are not worried about individual variables within that. You can confidently go about and analyze using parametric measures. But if the data set tends to be non-normal, then so there are simple tests you can do to indicate whether the distribution is normally distributed or not. And then you can go ahead and do your analysis. Kindly touch on how to word the null hypothesis and the alternate hypothesis. So let me explain quickly. Generally, the null hypothesis is usually what you really want to put across so that you can discard. What really you are interested in from the research you want to conduct is the alternate hypothesis. So there are ways of stating it, and it is always better at this stage. I will encourage that we do the two-tailed test. It's usually better. You don't take a direction, because if you state that you want to determine whether the weight of newborns, males or females, there are differences in the weights of male and female newborns, and you state your null hypothesis that the weight of male newborns are greater than that of female, you have taken a direction, and that is a one-tailed test. Usually difficult to explain. But if you stay in the middle, that there is no difference in the weight of newborn males and females, it could go either way. Females can be higher, males can be higher. So our advice for us, we should try and state it without taking a direction. The null hypothesis usually is what you state as there is no difference. But in fact, your research is to show everybody that there is a difference. And that is what your alternate hypothesis is about. That is why usually we will say that we fail to reject. We normally do not say we accept, because the null hypothesis is put there, excuse my language, it could be utter unreasonable or unacceptable. So you don't want to accept it. For your research, you want to reject it. So if you are unable to do it, then you say we fail to reject what in fact we wanted to put across to reject. So that is the null hypothesis. You state the null hypothesis like this, then you say that there is a difference, or this is higher than, or persons who smoke are at increased risk of developing hypertension. These are all ways of stating the null hypothesis. There is no one single way of doing that, but that is to say that it is always better. Your concentration is really on the alternate hypothesis. That is what you want your research findings to prove.
Alfred, there's an earlier question. Let me just read the ones I have here, so that will help you. It says, if a table is large, example, frequency table with so many variables, that you would cut across 2 pages, can you split into 2 and name them table 1A and table 1B?
I think that's always acceptable. If it is, for example, demographic characteristics, and you have a long table, there is no reason for you putting a long table that goes about 3 or 4 pages. You can describe it, as I said, a title should be comprehensive and let the table tell its own story. You can break it up. Table 1, demographic characteristics, this. Then other demographic characteristics of patient, something. You can always find words to break it up and make it simple to read.
Then
Yes.
There's a question here that says, is it compulsory to state all the measures of central tendency? Example, if it is skewed and you decide not to report the mean, does it matter? Some examiners insist all 3 should be stated. Maybe let me comment on that and give
Yes,
out the brief that you don't have to state all measures of central tendency, mean, mode, and median. No, you've got to report the one that matches the data that you have collected. And well, like I said, some examiners might insist on all 3, but then you can always explain to them that, hey, all 3 are not needed. I mean, I know some people may say that, but the truth is that you don't have to, for everything, say mean, mode, and median. And sometimes the mean doesn't make sense. Like in my field, ops and gynae, somebody tells me that the mean parity is 2.1. And I'm like, what does a parity of 2.1 mean? It doesn't mean anything. In that case, you want to tell me about the modal parity or maybe the median parity, because you want to give a measure of central tendency that matches what you're measuring. So mean, mode, median all the time, not necessary. Alfred, you want to add something to that?
No, Prof, it's all right. You really don't need to. And especially when it is skewed, the mean will not give you any reasonable estimate. So it's once you determine its mean, it's non-normal, it's skewed, you go for the median because that is the most preferred. And then it means subsequently you do non-parametric analysis. Yes.
Okay, there's another question here. It says, when the confidence interval is said to be too wide, even when it is on the right. I'm wondering what the right is. Maybe meaning that there's a positive association, whatever. On the right, what values are thought to be too wide? Well, I would say that it's hard to give a value and say that it's too wide. But we must ask ourselves kind of like what makes sense. For instance, let's say we are calculating the mean weight of university students. And you tell us that the mean weight, the confidence interval is from 20 kilograms to 120 kilograms. You might as well not bother doing the research. It's so wide that it's not useful.
It's not useful.
But we can't tell you that. It's like when we see an interval that's too wide, we know. But it's hard to tell you that the weight should be 5 or 7 or whatever. But once it's a bad interval, I think everybody would know that, because it's like it's so wide that there's no need going to calculate that mean. So I present the figure that people put to it these days.
No, Prof. It's exactly what you said. So let's say you are doing a bet weight, and then you say your mean is, let's say, 2.5, and the upper value is about 7. So it becomes 2 plus 7, so it's what? 9. And giving birth to babies, 9 kilograms. So as Prof said, you need to look at what you are measuring and see what is reasonable. It's really this worth pursuing. Yes.
Yeah. So Alfred, this one, they said, is regression analysis reported as odds or risk? You have used both terms. I mean, somebody wants to get you to put you on the spot there. So you want to speak about that?
Yes, bro.
Regression analysis reported as odds or risk? You have used both terms.
The regression analysis, yes. Let me take it a little basic and explain. We have a continuous variable. Let's say changes in fasting blood sugar. We measure it. And then there are independent variables. What it is basically doing is that when we pull all these factors together, let's say the weight, the BMI, all that, which of these on its own will cause the change that we see in the Y. So there is a change in Y. Then we say, okay, let's hold all the others constant and keep only BMI and see how much of the change that is occurring in the fasting blood sugar can be attributed to the changes in the BMI. We can also take the, apart from the BMI, compliance to medication. Let's say that. We hold all the others constant. And then we say that, okay, this change that is occurring in the fasting blood sugar, how much of that change is explained by the change that is occurring in the compliance to medication? So usually I will say that generally the logistic regression will indicate the odds. The regression ones can indicate how much of this is being explained and can be explained in terms of the risk as well.
Yeah, yeah. So I mean, the other thing I would add is that sometimes the terminology odds and risk.
Risk, yes.
If you ask an epidemiologist, the epidemiologist will tell you that if your study is not a cohort study or an what do you call it, or a clinical trial, you must talk about odds and not risk. It's only for cohort studies and then clinical trials that you use the terminology, use the term risk. This purist epidemiologist speaking, and I happen to subscribe to that. So we'll make you change all your risk to odds and not even be happy when you use the term likely, because it's different. There's a likelihood ratio thing.
Which is
these are just general things. I mean, nobody would kick a dissertation out because of that. It would just, the person would just say, use this terminology because it's more appropriate. It's more appropriate.
With your study design.
Yeah. Yes. Alfred, there's a question here. Is there a cutoff sample size to test for normality? I mean, I guess basically they're asking something like, is there a minimum sample by which you can say that what do you call it? The data are normally distributed. What do you think about that?
Okay, the general assumption is that if a sample is 30 or less, you are more likely to have a non-normal distribution, and that it should be more than 30. But as I said, you can always do simple tests to test whether your data set is normally distributed or not. You may even have some less than 30, but it may turn out to be normally distributed. But the principle, general teaching is that samples less than 30, generally, you need to be careful because it may be non-normally distributed.
Right. There's a question here that says, can you use logistic regression for categorical dependent variable which has more than 2 responses? And my response to that is yes.
Yes.
But the interpretation is what you have to be careful about.
Yes.
Let's say you have a categorical variable where your outcome is mild, moderate, severe. Mm-hmm. You can do a logistic regression. Logistic regression, when you do a logistic regression, you get an odds ratio. Let's say an odds ratio of let's say 2. What that means is that your odds of the outcome is increased by 2, moving from one category to the next. So the interpretation becomes a bit complicated. So maybe the simplest thing is to do it for when there are 2 responses. Then it's easy to explain.
Interpret, yes.
Yeah. So that's what I would say to that. But it can be used for more than 2 responses. One just has to be careful about how you write the interpretation. And Alfred, there's this one. It says, kindly go over how you generate the lower and upper limits of the confidence interval.
Okay. I think that's very important. Remember, we indicated the population 1,000 population from which we sampled and took 10 different samples of 100 each. And then we determined the means of these ones. Then we said each individual mean, when we pull them together, becomes a data point, and they themselves will then become normally distributed. Then we can have the mean of means from a single mean from these means. And then we said that these means vary from each other. And therefore, this variation within these means, we can calculate that. And when we calculate that, it gives us a value. So it gives us a value per the calculation, then it becomes positive or negative. So that value is about the mean. So if you calculate any standard error of 6, it means the mean plus or minus 6. And therefore, what you do is just to subtract the value from the mean, that gives you the lower one, add that value to the mean, that gives you the upper limit of the confidence interval. I believe that helps. So you determine the standard error of the means, and then that value is plus or minus the mean. That will give you the interval within which the mean sits. So you add it to the mean to get the upper level, you subtract it from the mean to get the lower level, the lower limit of the confidence interval, and then the upper limit of the confidence interval.
Right. So what Alfred has given is that's the technical answer. I mean, my answer would be know the right command, give the command to the software, it will generate it for you.
It will generate it for you. You don't need to, you just the explanation.
I mean, you don't need to work it by hand, but what Alfred has said is the principle behind it. So the last question here, Alfred, is saying that ideally, at what stage in the write-up do you state that you reject or fail to reject the null hypothesis?
Okay, so you will do your analysis, which is in the results section, but you don't do any interpretation in the result, ideally. So you will see that your p-value in the results shows this. You state it as it is in the result. When you are discussing, then you can state in the results that the p-value is greater than this, and therefore the null hypothesis is rejected or we fail to reject. Then when you get to the discussion, you interpret it in the context of what you are doing, as well as the objectives that you set. So in the result section, you do the analysis, you can state, because you have the p-value there. But the interpretation in the context of your objectives and the work you are doing, you can put it in the discussion. That when we did, the result showed 0.05, less than that, and it indicated A, B, C, and D in terms of the objectives. You can do that elaborately in the discussion.
Right, thank you, Alfred, for that presentation and dealing with the questions. So this essentially, like we said at the beginning, is to give us all a fair idea, refresher about the things that go into the statistical analysis, so that when our trainees bring these things to us, we'll be able to assess it and guide them. So thank you so much for joining today.